Hello everyone, welcome to SR Maths Learning. In this video, we are going to discuss the basics of probability, and in upcoming videos, we are going to discuss complete probability with the different probabilities. So this is my first video on the probability. Please keep watching my videos and encourage to make the more good videos on the different chapters, different topics. Okay, so what is probability? So a general idea, probability is nothing but more we will discuss on chances of happening. So about the events, about the random experiments. So there will be two kind of experiments we can see. One is deterministic experiments, means if you do experiment, whoever will do under the identical conditions, whomever you do this experiment under certain identical conditions, the results will be same. The result will be same. For example, if I take NaOH plus HCl, so its result will be NaCl plus H2O. So under the same conditions, same experiments, if you give to different persons, the result remains the same. These type of experiments are called deterministic experiments. And the second one is random experiment. Random experiment. This experiment is nothing but already we know the output. But unless we will do the experiment, we cannot get is what is the exact output. So for example, tossing a coin. We know the actual output, what we are going to get, possible outcomes. I'm talking about the possible outcomes. If I'm tossing a coin, I'll get either heads or tails. But we cannot say exactly what will come. There is a chance of getting heads, or there is a chance of getting equally tails also. So another example, tossing a pair of coins. Tossing a pair of coins. Otherwise, rolling a dice, drawing or taking out a card from deck of cards. So these are all the random experiments. Actually, we know what will be the possible outcomes. Okay, so here one more thing, what we have to know, the term is event. So it's nothing but like it comes, this terms comes from the experiment, random experiment. So it's nothing but a trial. Event is nothing but a trial. So like if I'm tossing a coin or rolling a die. So in the rolling a die, getting a prime number less than 5 is an event. Getting a prime number less than 5 is an event. So event is nothing but a trial in the experiment, what we are doing, right? So next, what is the sample space? What is sample space? So it is nothing but set of all possible outcomes. Set of all possible outcomes of a random experiment. That means I'll give the different examples here. If I'm tossing two coins at a time. So what will be the output? On the both the coins, we can get heads and heads, or heads and tails, or tails and heads, or both are tails. So if we keep this in one set form, we can say this is a sample for this experiment. So like this, in an experiment, all the possible outcomes, if you keep in one set, so that is called sample space. So let's see what we will get the sample space for the different experiments. Like in general, what we will get the questions. So let's see once. So particularly here first, I'm talking about coin. So when we'll toss a coin, tossing a coin, tossing a coin, what you'll get the sample space is either heads or tails. That means number of elements in the sample space will be 2. So second thing, tossing 2 coins at a time. Tossing 2 coins at a time. So when we toss the 2 coins at a time, the sample space will be heads, 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 tails, tails, heads, tails, tails. So this is the sample space. So here, n of s will be 4. That means 2 square. Tossing 3 coins at a time. Tossing 3 coins at a time. Tossing 3 coins at a time. So sample space will be like this. So we can take easily up to 3 coins. After that, little difficult to write all the possible outcomes. Heads, 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 tails, heads, tail, heads, tail, heads, heads. And the next one is the tail, tail, heads, tail, heads, tail, heads, tail, tail, and all the tails. Right? So here n of s means number of elements in this sample space will be 8, which is nothing but 2. So if you generalize this, for if tossing n coins at a time, tossing n coins at a time, tossing n coins at a time. So the number of elements in the sample space will be 2 for n. So we should remember this for further problems. So next, coming to the dice. So coming to the dice, if a single die rolled once, single dice rolled once, rolled once. So what you get the sample space is 1, 2, 3, 4, 5, and 6. If two dice rolled at a time, if 2 dice rolled at a time, the sample space I'm writing here full. So on the both the dice it will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, or 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. So this is the way how we will get numbers on the both the dice. So 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So this is a sample space. when two dice are rolled at a time. So n of s will be 36, which can be written as 6 square. Here, n of s will be 6. If n dice are rolled, if you generalize, if n dice are rolled once, so our sample space will be here. N of s is equal to 6 power n. So this is about the dice. So next comes to the deck of cards. Pack of cards or deck of cards. Deck of cards. So in this, generally, we have total 52 cards. So out of this, 26 red, 26 black. Correct? So out of this again, under red color cards, hearts and diamonds, and under the black color cards, spades and clubs. So here hearts and diamonds, spades and clubs will be. So here each 13 cards, and these are called suit also. In certain problems, they'll ask like suit. So each 13 cards, it will be number like ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and J, Q, king. So here also ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. Here also ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. So out of these 52 cards, what we have to remember is number of ace cards. 4. Number of J cards, 4. Number of Q cards, 4. Number of kings, 4. So this J, Q, K are called face cards. So that's why number of face cards in total, 12 cards. So this is the information what we have to remember. So about the pack of cards. Next comes to the years. So first one is non-leap year. Second one is leap year. So non-leap year, we have 365 days. In this, 52 weeks into 7. So 7 2s are 14. 1, 7 5s are 35. 36, 364 days plus 1 extra day. So that day, whatever it may be, like from the Sunday, Monday, Tuesday, Wednesday, Friday, Thursday, Friday, Saturday. So any one of these, it might be that one day. So total 52 weeks means 52 Sundays, 52 Mondays, 52 Tuesdays, like that we will get all days 52, 52, 52. Comes to the leap year, here 366 days. That means 52 into 7 plus 2 extra days. 2 extra days. These 2 extra days may be like Sunday and Monday, Monday and Tuesday, Tuesday and Wednesday, Wednesday and Thursday, Thursday and Friday, Thursday and Friday, Friday and Saturday, Saturday and Sunday, any one of these combinations. So in the non-leap year, February month having 28 days. In leap year, February month having 29 days. So please remember this complete information, the problems. Okay, so here I'm going to discuss the classical definition of probability. Classical definition of the probability. Classical definition of probability. So what is the classical definition of probability is, let A be the any event, let A be the any event, A be the any event of a random experiment, then probability of A is equal to number of favorable outcomes, number of favorable outcomes divided by total number of outcomes possible in that experiment. This is the classical definition of probability. So here what we have to notice, probability of an event always less than or equal to 1 and greater than or equal to 0. So we have to remember this. So with a simple example, I will close this video, and for remaining, please watch my videos. So let's see one example here. A pair of fair dice. A pair of fair dice is rolled. Find the probability of getting a total of 6. So this is question. So what we know, a pair of dice rolled means our sample space will be 36. So n of s will be 36. Here, let us assume A be the event of getting some 6 on total. So if you look at what we discussed about the sample space, here where you are getting the sum as the 6, see here, 2 in this sum is 6, 1 comma 5, 1 plus 5 is 6, here 2 comma 4, 3 comma 3, 4 comma 2, right, 5 comma 1. So these are the 5 different ways we will get, right? So here if you look at our favorable outcomes, sample space is getting like this. Our A will be 1 comma 5 and 5 comma 1, 2 comma 4 and 4 comma 2 and 3 comma 3. Means we are getting n of A will be 5. So what is the probability of getting a sum is 6 is 5 by 36. So this is number of favorable outcomes. So these are the total outcomes. So hope you understand. So thank you very much for watching my video. So here we are going to do many problems under this probability videos. So please keep watching my videos. Please follow my Instagram and my Facebook. So please subscribe to my channel. Thank you.